Now we have a next topic, that is De-Broglie waves. So let's see. So De-Broglie says that whenever a material particle, right, are in motion, they behave like a wave, known as De-Broglie wave, and the wavelength associated with it is known as De-Broglie wavelength. Now we have to derive the formula for De-Broglie wavelength. Okay, again I'll try to write and explain to you. Let's see. De-Broglie wavelength. Since according to Einstein, E equal to what? mc square. And according to Planck's, E equals to what? H nu. See, these both are energy. So we can equate and write mc square equals to H nu. So mc square, what is nu? We can write C by lambda. Now C and C gets cancelled. Lambda will be equals to H by mc. Correct? Yes. We have this. So this is our De-Broglie wavelength. But this is for what? For photons. Now how did we know this is a photon? Because here I am using a what? A letter C. And C means velocity of light. And only photon can acquire velocity of light in vacuum. So this is a photon. So he said that if this is true for photon, it must be true for other particle, elementary particle as well. That is electron and all. Right? So then he modified, he wrote it as m into v, where v is the particle velocity. Okay, v is particle velocity, which here v is less than obviously c. Now this is the expression for De-Broglie wavelength. Now this De-Broglie wavelength we can write in various forms like kinetic energy, in terms of potential. Fine. So first h by m p in terms of momentum. In terms of momentum, right? Now if I want to write in terms of kinetic energy, what? In terms of kinetic energy. Then how to go about this? Since we know that kinetic energy is half mv square, so how do we write? Multiply m, it will become m square v square divided by m. So it is 2mk. Am I clear? So mv, this is whole square.
So why multiply?
Because see, I need to get this mv. And here with m, I don't have square. So I cannot bring them together. Okay. So in order, if I make square with m, then mv I can write whole square. And then make my mv separate.
Yes, sir.
So just a manipulation here.
Yes, sir.
So here 2m I will take that side. So I'm getting my mv as what? Root over 2mk. Therefore, I can write my De-Broglie wavelength, which is h by mv. So in place of mv, I can write root over 2mk. Right? This in terms of what? In terms of kinetic energy. Suppose I want to write in terms of potential. What? Potential. In terms of potential. In terms of potential, I can write kinetic energy as q into v. So lambda will be equals to h root over 2m. In place of what? K, I can write q into v. So this is in terms of potential. Now for electron, specifically for electron, if I go, then I have to write this as 2mev. Right? Now we know the value of Planck's constant. That is how much? 6.63 10 to the power minus 34 divided by root over 2. Mass of electron is 9.1 in 10 to the power minus 31. Right? Charge of electron 1.6 minus 19, and then I'm left with potential. Now if I solve it, I'm going to get a value 12.3 by root v in terms of Armstrong. So this value also should be remembered, because there might be a direct question where they might give you a potential and you'll ask to find De-Broglie wavelength for electron. Am I clear? Thank you.